Global warming is one of the most serious challenges facing mankind today. To solve this challenge, we must act now and reduce global greenhouse gas emissions by up to 85% by 2050. The good news is that the solutions needed to cut emissions this much already exist. One of them is carbon dioxide capture and storage, or CCS. Today, approximately 50% of the world's man-made CO2 emissions come from burning fossil fuels in power plants or factories. These emissions can be virtually eliminated if CCS, that is CO2 capture and storage, is implemented. The physics and chemistry taking place in CCS is complex, but I will give you a brief explanation of how it works. In the cleaning system shown here, the CO2 is removed from the flue gas after the combustion of the fuel in the coal power plant. The flue gas enters the first tank of the CO2 capture plant. The flue gas consists mainly of CO2, nitrogen gas, and water vapor, in addition to smaller concentrations of several other compounds. The black particles entering the CO2 capture plant represent carbon dioxide, while the green particles represent harmless gases like nitrogen and water vapor. Blue particles entering the top of the capture plant are a chemical, also called solvent, that can react with the carbon dioxide. Once the solvent has reacted with the CO2, it leaves the first tank and is pumped into the second tank. The solvent is now heated, and as a result, CO2 is separated from the solvent. This process produces one gas stream of pure CO2 and one liquid stream of pure solvent. The heating process requires a lot of energy, and it is this step that makes CCS rather expensive today. However, research activities are ongoing worldwide to reduce this energy loss and thereby the costs. Pure CO2 leaves the top of the tank ready to be compressed and transported to a safe storage site. In most cases, suitable storage sites are located at some distance from the power plant, and pipelines or ships are therefore needed to transport the CO2. Storage locations, such as porous rock formations, are found throughout the world. At the storage site, CO2 is injected into geological formations located at least 800 meters underground. At this depth, CO2 is in a liquid-like phase, which minimizes the possibility of CO2 escaping from the reservoir. Monitoring techniques which measure the pressure of the storage site as well as seismic sensors are used to keep track of the injected CO2. In the event a leakage occurs, proper monitoring enables us to take measures to stop the leakage immediately. However, leakage is very unlikely in a properly selected and operated storage site. Scientific studies indicate that more than 99% of the CO2 will most likely remain safely stored after thousands of years. Three mechanisms ensure that the CO2 does not leak but remains safely stored in the reservoir. The first mechanism is physical trapping. The CO2 which is stored in a porous geological formation will try to move upwards, but is stopped by the solid rock above it, called cap rock, which the CO2 cannot penetrate. The second mechanism is dissolution. Over the course of decades and centuries, the CO2 will dissolve in the salt water found in storage locations. The third mechanism is mineralization. After thousands of years, the CO2 will react with other minerals to form solid rocks like limestone. At the Bellona Foundation, we are working hard to make sure that the world's business and political leaders rise to the challenge and take concrete measures to combat global warming, like deployment of CCS technology. You too can make a difference by educating yourself about global warming and its solutions, and by joining us in the battle for action. Visit our new Bellona CCS web to find out more about how CCS works and how it can reduce CO2 emissions and global warming.